Hello students, in this video what you are going to learn is the different forms of positive integers when we are dividing by 3. For example, we are going to take first 5 positive integers and we are going to divide by 3 and we will see what are the things are going to happen or what are the reminders are we getting. Let me take that first 5 positive integers. This is 1 to 5 and I'm going to divide these numbers by 3 and we're going to see that what are the reminders we are getting. So if you divide 1 by 3, we cannot divide it, right? So it goes 0 times. So 0 times 3 is 0 and we subtract, we get the reminders 1. How can you write this in Euclid division lemma? So divided is 1, the divisor is 3, and the quotient is 0, the remainder is 1. Let us take the second number 2. 2 also cannot divide by 3. So we won't get a, because there is no 3 in 2, right? So it goes 0 times. So we put 0 here, 3 into 0, 0, remainder is 2. When we write this as in the form of Euclid division lemma, so we can write as divisor 2 is equal to dividend 2 is equal to divisor 3 into quotient 0 plus remainder 2. Now let me take the next number 3. 3 divided by 3, it goes one time. 1 3 is 3. Then when we subtract, the remainder is 0. So how can you write this in a Euclid division lemma format? That is, dividend 3 is equal to divisor 3 into quotient plus remainder 0. Now observe what are the reminders we got: 1, 2 and 0. 1, 2 and 0. And we are going to divide a next number 4 and 5. Okay. So 4 we are going to divide by 3. So it goes one time, 1 3 is 3. When we subtract, we got the remainder as 1. In Euclid division lemma format, the dividend is equal to divisor into quotient plus remainder. Then we are going to take a next number 5. 5 we are going to divide by 3. It goes one time. So 1 3 is 3. When we subtract, the remainder is 2. So the Euclid division lemma format, 5 is equal to 5 is the dividend equal to divisor into quotient plus remainder. One more number we can take it, that is number 6. Okay. So 6, if you take 6, it goes divide by 3, it goes 2 times, 2 3s are 6. When we subtract, the remainder is 0. The Euclid division lemma format, 6 is equal to 3 into 2 plus 0. Let me take one more number, 1 or 2 numbers, so that we can see what happening in the reminders. 7, next number I'm taking for to make you to understand more examples. With the more examples, we can see this. 3, we are going to divide by 3. It goes again 2 times. 2 3s are 6. The remainder is 1. So we can write as 7 is equal to 3 into 2 plus 1. Another number. 8. It goes 2 times. Dividing by 3, it goes 2 times. 2 3s are 6. When we subtract, we get the remainder as 2. So we can write as 8 is equal to 3 into 2 plus 2. If you observe the reminders, we're getting only 0, 1 or 2, right? See, if you see 1, 2, 0, again 1, 2, 0, 1, 2. So it is repeating, right? 0, 1, 2. So we can understand that every positive integers we only get, when you divide by 3, you only get the remainders 0 or 1 or 2. These three numbers repeating. We can write a common form for it, right? So we are dividing by 3. Every positive integer means we can take this every positive integer as a, okay, and its format, we are dividing by 3, so we can write as 3. If you see that this quotient we got 0 and then we got 1, then again we are getting 2. It will change to, after 2 it will increase to 3. So quotient is changing, so we can write the quotient as another variable with the q. So what is the remainder we are getting? 1, 2, 0, 1, 2. These three numbers are repeating. So we can write as plus 0, or a is equal to 3q plus 1, or a is equal to 3q plus 2. This further we can write as a is equal to 3q. So every positive integers we can write in the form of either 3q or 3q plus 1 or 3q plus 2. Using this, our idea of understanding about the format of positive integers when we are dividing by 3, we are going to do one question problem. It's on the screen. Show that any positive integer is of the form 3q or 3q plus 1 or 3q plus 2 for some integer q. So the question, it says that we should show that every positive integer is of the form 3q or 3q plus 1 or 3q plus 2. Okay, as we did for the first example question, that we proved that every odd number is of the form 2q plus 1 and the even number is of the form 2q. Same method we are going to use here also. We are going to use Euclid division lemma. For that we have to define, or we have to take two numbers a and b. Here we are taking a as a positive integer. So we write that let a be any positive integer, and the divisor here is 3. So b is 3. Okay. Then by Euclid division lemma, there exists a quotient and a remainder, such that it is in the format of a is equal to 3q plus r. Now we have to say how q can be written, or what is q and what is r. Here r is a remainder. We know that the remainder will have the values it is greater than or equal to 0 and less than 3. Okay, which means equal to 0, so r can have value 0, greater than 0, so it can have 1 and 2. It cannot go up more, less, r is less than 3, so it cannot go more than 2, right? It stops here. So r can have values 0, 1, 2, and q is some integer which means q is some integer. It can have any value. Q can have any value. It is an integer, so it can have positive integer. You are only taking positive integers. Okay, and positive integer, some integer we can have it. So it can have zero also. So we cannot say only positive integers from 0, 0, 1, 2, 3, etc. We can take it. So if you are substituting the values of 0, 1, 2, if you substitute in the place of r 0, we get a is equal to 3q. If you substitute 1, we get a is equal to 3q plus 1. If you substitute 2, we get a equal to 3q plus 2. Only it can have these three forms because the R is deciding this the format here. So from this we can understand that any positive integer can have only these three forms. A is equal to 3q, 3q plus 1, 3q plus 2. Since the R is less than 3, it can have only three values from 0 to 2, 0, 1, 2. Using that format, we can write only three forms. So we conclude that any positive integer is of the form. Therefore, any positive integer is of the form 3q, 3q plus 1, 3q plus 2 for some integer q. I hope you understood. As I said earlier, if you have a doubt, you can call me and I'll clear it. Thank you for watching.